Thank you everybody for attending our webinar on our FourierBMS equipment. As Pav said, my name is Mark Errington and I'm one of the directors here. And Pavlos is one of our senior engineers, and he also leads the R&D team. But first of all, just a very brief introduction to the company and how we are involved with belt measurement and belt tension. The company was founded in 1980s, and it built up a reputation with producing equipment predominantly in the automotive industry by having a joint partnership with a local university where we developed the ability to detect belt vibration through acoustic method. So we had, with our application, we had a microphone either side of the belt, and then we could, once the belt had been agitated, we could pick up the sound waves of the belt vibrating, and we were able to detect the frequency of the belt. So this allowed us to take this technology and method into the automotive sector, where we were in the 90s making equipment for we call them the radio plates. So this was a plate that was mounted to an engine, an automobile engine. It would have an automatic hammer that would strike the belt, and then we would have a power tool that did the adjustment of the belt through the idler, and we could determine not only when to stop the tension, but also the frequency of the belt as it reached its target tension. And that kind of like led us into sort of big production facilities. And alongside that, we've got our handheld service meters that maintenance guys use to do spot checks on belts, or when they're replacing timing belts on engines, they can make sure that the tension's correct as a service after sales. So the company's really been involved with belt tension for 30 plus years. Of all the years that I've worked for Clavis, we've been heavily involved with across lots of sectors measuring belts. So really, what I'm trying to say is, measuring belts is not new to us. It may be new to you, it may be new to your clients, but to us, we've got a deep history and deep knowledge of what we're trying to do in terms of measuring belts and looking at signals and analyzing the signal quality from belts as they're vibrating. And hopefully our webinar that Pav will proceed with will give you some more information. I'm sure you're going to have plenty of questions, and I'm sure that afterwards you may forget some questions you would like to ask. And if you do, please don't hesitate to contact us via email or even pick up the phone if need be. And me and Pav will support you and your clients going forward. So I'll pass it over to Pav, and if you, like I say, there'll be questions at the end, and I hope it's informative. Over to you, Pav.
Thank you, Mark. As Mark said, we have a variety of equipment with regards to belt tensioning. Today, we're going to speak about the FourierBMS, and which is for measuring the belt tension. There are two key parameters that someone needs to check or when it comes to a belt pulley system. One of them is the correct alignment between the two pulleys, and the other one is the belt tension. We're going to speak about the belt tension, and this is what the FourierBMS does. It's there to measure the tension of the belt. And in the worst case scenario, if the belt is not tensioned correctly, it can lead to a catastrophic failure of the engine itself, because all of a sudden, from the load that it had, it has no load and can spin freely, which actually can tensioning your belt correctly, it can avoid this costly downtime of such failure. What is the FourierBMS? It measures frequency, and based on this frequency, we can have an idea of what the tension is. The frequency is given in hertz, but then we can actually extract the tension of the belt into pounds or newtons or kilogram force depending on what the customer needs. To do that, we need the mass and the span of the belt as well. So our most common application is the electric power assisting steering system, or as known as the EPAS. But we have systems they run into the vehicle and engine assembly, into auxiliary belts, and most recently we had some requests for the belts that they run the refrigeration units in the transport vehicles. It's been used over by over 1,000 customers worldwide. Now, how does it actually work? Is that we have a hammer that agitates the belt, and we have a system here where it measures the frequency, the vibrations, the actual vibrations coming from the belt. So, in a sense, we are recording how a specific point of the belt vibrates, and hence we can determine what the frequency is. Long story short, when the tension is higher, the frequency is higher as well. So as I said before, the system can record from anything from 30 Hertz up to 800 Hertz. 500 Hertz is the standard frequency that we can measure, but we can go up to 800 Hertz on demand. And this is the solenoid that agitates the hammer, and it's a standalone module where nothing else is needed. Now, for a closer look, this is the BMS 01. This is one of the basic models, and we have indications on the front of the slack OK tight that indicate whether the belt is set to the correct tension given and provided by the plant. And we have a selection of buttons here where we can actually hold or save the FFT on the display. We have a USB port in order to do that, so we can save all of the files, all of the images. We have a run, a calibration, and log to FFT. So we can actually look at both the raw data, aka the vibrations coming from the belt, or we can look at the FFT, which we are going to talk about a bit later. And also we have a quality factor, which is an easy way for the operators or the process people to determine whether the quality of the vibrations is correct. And then we have the display for the frequency. On the top of the cabinet, we can see that we have a lot of IOs and the ability to have a light stack as well. We have RS-232 communication, and then we can have Ethernet communication as well. These are inputs for the heads that we've seen before, and we're gonna talk about them later on as well. So what can be logged in the system? We can log the frequency or the tension in newtons, given that we know the span and the mass of the belt, and we can actually save the configurations and log any other events that the plant might need. I think I skipped, or this is the BMS 01. So what are the challenges? I mean, this is a process in real life process that we have. In an ideal world, the belt would vibrate into one frequency, and that would be according to the functions that we have from the maths. But this is nothing. This is not even close in reality. So the belt can vibrate into many modes. It can vibrate in the width mode, and it can vibrate in the length mode, and it depends also on the alignment of the belt, of the pulleys, and that leads in uncertainty in measuring the frequency. All of these components, all of these different frequencies, actually create a complex waveform and that needs a lot of analysis in when looking at it in the raw data. So in order to obtain to obtain the actual tension out of all of these frequencies that exist within the belt, we have to go in the frequency domain, and that is the solution. So in the frequency domain, we can see that we have the dominant frequency here at 100 Hertz. And we have other components here. This should be the width frequency, dominant frequency, where we are not interested in. So this is the way of knowing what the tension of the belt is. So we have little bins that we can determine what the dominant frequency is. And then up here, we have the quality factor, which determines that the quality of the signal is good, and the scale factor, which means that we have a higher amplitude when it is above 2 or above. So what is the fast Fourier transform? It's essentially we categorize its frequency. The analysis is taken from the time domain. So that means that when we have a good quality in the time domain, so we have good vibrations in the time domain, then we get good quality on the Fourier domain as well. Quality factor can take can be anything from 0 to 9. Actually, a lot of plants, different plants set the standards for their quality factor. So the threshold where they would accept that a signal is okay or not okay, but usually this number is 7. So any signal with quality factor from 7 or above, it is accepted by most of the plants. So this is the other end of the cabinet, where we have the sensor head, where it is mounted onto the unit, or it can be hovered over the unit, and the unit can pass via the production. We have a huge variety of different types of sensor heads. We have the compact, long reach. This is the compact, the long reach, adjustable, and handheld. Now, the handheld devices, of course, can be used by the operators, and they can be inserted onto the belt for measuring. We've created so many variations based on the application that the customer has. So, for example, if we would like to have more than one different units within the production, then we need to have an adjustable sensor head. Or if we have a small, if we have a standard EPAS or a standard belt, then we can use the compact. Or the long reach is for applications where we cannot reach easily the belt, or we don't have good access. Now, to speak about the two mostly used sensor heads, this is the compact sensor head. We have the hammer here and the optical sensor on the other side. And this is just the standard design. We can have this connector on any of the side depending on what the application is. So even with the compact sensors, we have a variety of different designs in order to accommodate for different belt designs, depending on the on what how accessible the cable can be. And then here we have the long reach sensor. Mark is going to talk about it a bit, about this specific application, why this specific sensor was developed. Over to you, Mark.
Okay, thanks, Pav. Just to touch back on Pav, if you want to go one slide back for me, please.
Sure.
Maybe one more where we've got all of them. Yeah. Okay. So just to explain a little bit more about these heads. As Pav said, we've got a catalog now. I think we're up to 68 of different designs and shapes to try and meet all of our customers' needs and constraints on the point and where we're measuring the belt. So, and we design and manufacture all of this in house. We've got all the capabilities to produce bespoke sensors in different. As you can see, there's a push button on the long reach head. Sorry, not the long reach, the handheld one. So what that does is that can be a button there that fires the hammer as and when the operator places the head over the belt. So just because we've categorized them into this sort of 4 categories, we can do anything. We can really produce whatever is needed for your application. It doesn't need to be confined to a rectangular shape or whatever. We've got full flexibility to change that to suit. If we go back to the slide, the long reach slide, please, Pav. Okay, so this is a long reach sensor head, and this is developed for an HVAC customer, one of ours, where he is going to actually use this head with the FourierBMS 01, which is the closed loop system that we've got. So this is fully integrated with a power tool controller. The operator places this on top of his generator frame. He then you'll scan the barcode of the unit, and then the system will automatically start taking a reading from the belt. You'll then manually adjust it with a power tool, and as the data from the sensor head is transferred to the control cabinet, when it reaches its target tension, it will just stop. So all the operator has to do is locate the sensor head in position, pull the power tool trigger, do the adjustment, and then off he goes. There is an extra button on there in case. Sometimes, not all cases, we have the ability to manually start the hammering process of the head. Now, because we've got such knowledge of what's really required within the production environment, we don't leave full control over to the plant system. So let's say for whatever reason, the plant communication goes down, but you still want to, use this head manually. Well, you can either do this by pressing the run button on the front of the control cabinet, or by pressing the run button on the sensor head itself. So we kind of know what most manufacturers need, certainly in the automotive industry, and depending on what your client does, we may come across something else that they require, but we're yet to fail on any kind of request from a client of what they want added to the system. But we've tried to cover as many bases as possible, and we think we've done that with the BMS 01. It has everything in there. So the beauty of this is once it's fitted to the frame of the generator, it's kind of held in place by magnets that go over the studs, and it does its job as it's designed to do. If we go to the next slide, please, Pav. So as I just touched on there, this is the sort of closed loop system where it's integrated with a power tool controller. And this power tool controller can be Atlas Copco, or it can be Stanley, or it can be Ingersoll Rad. You can integrate the BMS or all of our equipment with any power tool controller supplier, and it'll work seamless. So the operator has only really got 2 jobs to do. He just puts the sensor head onto its application, and then pulls the power tool trigger, and it's all automatic from there. The beauty of this is the speed, the repeatability, and also more than anything else now, as we progressed over the years, as I said very early on in the introduction, we've been doing belt tension for the automotive industry for a long time now. But in the early days, they weren't bothered about data. We didn't have the ability to store the tension and against the VIN number or the identification number of the application. It was all just left to us to show a red or a green light. But now, of course, data is and traceability is key to any application. in the production world or mass production world of people's applications and products. And this does it all. If you go to the next slide, please, Pav. And this is a quick video of what I mean by the ease of the operator's job with the closed loop system, where the tensioning and the measurement is required. So here we've got a setup of a belt and a pulley. The operator locates the sensor head into position, picks up the power tool, and off he goes. So the power tool is adjusting the belt. You'll notice that, different speeds of the power tool controller. That's because there's different strategies at different points. So as the tension of the belt increases, we downshift the speed of the tool to get high accuracy at the setting. You can have light stacks to, because we appreciate that sometimes the controller may not be in a position for the operator to easily see. So we've got a light stack the ability to give him another visual position to see whether the process has been okay or not okay. And these light stacks can be simulated to say slack tight or okay, or systems passed or failed, etc. So they're just another means of giving the operator something else to look at if he, for whatever reason, he may have his back towards the control cabinet and he doesn't want to be turning around and keep on checking what's happening. But generally what happens, you find that after a month or so of using our equipment, he can just gets a good feel for things, and it almost becomes a point where he knows whether it's going to pass or fail, if it was ever going to fail, because he's just so used to the system and how it works. Thanks, Pav. I think Pav briefly touched on this, on the alignment, pulley alignment. Now, he's right in pulley alignment can play a critical role of how a belt vibrates and the tension across the belt. And when across the belt, I mean across the width, because if the pulleys are misaligned, the tension may be high at one point and low at the other. Now, we can't do anything about that in terms of when we're just measuring. But if you integrate the measurement with some pulley alignment, which we have done for a client in the HVAC industry, we've done the alignment first, taken the data, and then tied it in with the tension data of the belt. So they've got an absolutely bomb-proof traceability of both pulley alignment and belt tension in their facility. And how we do that is we mount a laser unit onto one pulley and beam it across to the other one and take a profile image of the pulley. And then we've got a bit of software that analyzes the profile and determines whether it's aligned or not. So it really does work well for our client, and it's been a good success of ours over the last couple of years of what we can provide to clients going forward. And because it's a bit like it's a bit like what we've done with all of our other products. It's not something that we've got a huge sort of history with, but over the last 2 years, it's becoming more and more popular, and the interest is there. So we've got next slide, please, Bob. If we look at the software, it's just some basic software that just says, okay, the two vertical blue lines are my sort of range of acceptance, the tolerance of what they accept. So if center is absolutely in line, and you've got sort of 0.5 millimeter clearance or plus or minus 0.5 millimeter tolerance, as long as you're in that sort of vertical column, you can say that the pulleys are aligned. So yeah, that's just something else we can offer that kind of fits in well with the FourierBMS, that because the FourierBMS is looking at the belt signal. Well, we've got to look at all the influences that can occur with belt signal. Maybe depending on the pulleys and how your application is designed and built, they have a key role to play.
Right. So if I can do the conclusion, Mark. We started. Thank you for the presentation as well. Mark started by saying that we've started with belt meters. Belt meter is a handheld meter that can be used in order to verify what the frequency or the tension is on a specific belt. And we have a huge variety of belt meters. We have acoustic or optical, and we have different variations when it comes on to shape, what they measure, what kind of outputs they have, and what if they have a hammer as well, let's say, or if they're getting agitated by hand. Then the purpose of this specific webinar is to touch BMS. Now we have two types of FourierBMS. The one that we've touched mostly is the closed loop system, which has everything in, which is the BMS 01. Now the BMS 01 has the ability to do a lot of protocols. It has the ability to communicate with Profibus Profinet in order to hook it up into it has a PLC inside as well. So we have the ability to have RS-232, which is something standard, something more common seen in the industry. And then we have certainly the ability of the closed loop. So that means that the process can be done from beginning to end by a press of a button. And this is the absolutely maximum, the absolutely highest product that we can offer. Now, another product that we have is BMS 03, which can only give an indication of what the frequency is. So we are not controlling the process, we are not readjusting the belt, but we provide assurance that the frequency is correct or incorrect. With again, we have slight slack tight, okay. We can have communication via RS-232 with the system. We can provide this information. We can store the graphs as well. We can store the either the vibrations or and or the FFT, and we can provide again the information of the slack tight, okay, and the frequency as an output. Then we said in the beginning that this is one of the two components that are important in a belt and pulley alignment, a pulley, belt pulley system. The second component is the alignment of the pulleys. So we have another system which we've implemented with a couple of customers, where we can actually align the two pulleys before we do the belt tension. And we can do that in Z-axis, so that means that it's in one axis dimension by reading the profile of the pulleys. And the most important thing, just to summarize, to end the summary, is that let's say 50% of our products were built upon request. The other 50 were built by us. But that explains that we can actually manufacture or create or redesign our products based on the customer needs. And that's the most important things, because we have the facilities to do to design, manufacture, and create anything, any system that is required for any given problem. As an example of one client just reached us and asked us to measure the tension of a rope wire. So we are seeking for new products, new applications every time and every day. You have anything else to add, Mark, onto that?
Yeah, just a touch on what Pav just said there. We also the FourierBMS is particularly, you know, you may think on bigger belts and things, but we've also had a request where a client came to us and he asked us to measure a belt the size of an elastic band. So this is about 4 mil in width, about 100 centimeters in circumference, and this belt is going to be used on little motor that he's trying to design for electric handbrake. So they came to us and said, could you look at measuring the belt frequency, because at the minute electric handbrakes are mainly geared, and gears are quite expensive, whereas a little pulleys and a little belt is very cheap, and we've been able to successfully obtain the belt signal as it's being as it's getting agitated through a little pin hammer. So we've been able to reduce the size of our optical sensors to suit his needs, which opens up the window of the applications we can do. So I'm thinking like little robotic belts for robotic arms. They're all now within our reach. We've if you remember back to the beginning, or one of the slides in the webinar, the long reach sensor head, typically that had an outer diameter of 18 millimeters. We've now been able to reduce that down to 11.5, I believe. So if the access to a belt is through a circular hole, and as long as that hole is bigger than 11.5 in diameter, we can get our sensor down through the hole, agitate the belt, and then obtain the belt signal from it. So I think it's not just heavy industrial belts that we can do. We can do more sort of delicate belts, for a better word. Anything where the belt, any application where there's a need for belt measurement or belt tensioning, where there's a need to actually control the adjustment of the belt. We feel there's nobody better than us out there, and we've got a long history of working in this area. Thanks, Pav.
All right. I think we can go into the questions and answers. Feel free to ask any questions. You can raise your hands, as we said. You can unmute yourselves as well. And of course, if you don't have any questions and you would like us, you can get in contact with us, and we can actually discuss anything you would like. If you have a specific application, if you have further questions regarding our products, or if you would like consultation about any specific project that you have in mind. I cannot see any reactions, so yeah, there is that 2 questions. So can we start with Brian?
Yeah, I got one question on the handheld, the BMS measure tool you had. Do you see a difference in measurements or variation with how stiff the operator would hold their hand?
Yes and no. You do. We have got. We do have some clever electronics that limits the handshake, as we call it, from the operator, to limit the influence that he may have if his hand is bouncing around the belt. But generally, on depending on the type of belt that you're using with, certainly with auxiliary belts, they tend to vibrate easily. So therefore, it's easier for us to determine whether through the FourierBMS we can determine its the signal purity from it, and therefore give you a good indication that the belt is actually resonating and we're getting a good signal from it. So the answer is yes. With a handheld, you do have to consider handshaking from the operator, as opposed to having a permanently fixed head that is either, as Pav said, through a robotic arm that puts it into position, hovers it above the belt, and then agitates it, versus, you know, having a handheld and putting it into position. But depending on the belt, really, it will determine whether that's more challenging or not. I hope that answers
Yep.
your
Thank you.
question. Yeah.
And we have another question from John.
Yeah. So I still haven't reviewed. I've got a customer that has he's maintenance people that want to be able to measure the belt frequency, and I haven't viewed it yet, but I see you have like a type 5, a type 7, you have the various models. Is there a way you could kind of tell me the main differences between as you work your way from the least expensive to the most expensive?
Yeah. So our acoustic meters are the cheapest, and we for every model there's an acoustic version. Acoustic, as I said, is just measuring the acoustic sound from the belt as it vibrates, but you must have the jaws must go either side of the belt, because the beauty of our acoustic sensors versus our competitors likes of Unita meter and I forgot the other word, the Gates sonic meter, etc., is we measure the acoustic sound by having a microphone either side of the belt, and the reason we do that is to cancel out one is looking at the vibration of the belt, the other is canceling out the background noise. So that makes our acoustic sensors better, but depending on the application, you may find that you need an optical sensor because it's you know the optical sensors tend to work much better down the lower frequency, and because you're with acoustic, you're putting a belt between the jaws. If it's a very tension's not very high, your belt would clash against the jaws of the acoustic sensor. So that's where the optical sensor comes into its role, where it doesn't matter, it hovers above the belt, and you can allow the belt to fluctuate freely without having any obstructions. So we do we've got a type 3, a type 4, a type 5, and a type 7 that we sell. We start off with the bottom, the 3 and the 4. They're simply just a frequency meter, so they'll only read the belt and give you a frequency output. The 3 goes down to 7, or if you want to specialize, down to 4 hertz, up to 300 hertz. The type 4 goes from 30 hertz to 600 hertz. And you've got that both in acoustic and an optical sensor options as well. So with the type 5 can it has some inputs where you can, if you know the span and the mass of the belt, you can actually input this data into the type 5, and then when you collect the frequency of the belt, it will convert that frequency into tension for you into newtons and kilogram force. The type 7 is the same, but it does pounds and newtons. So the real key difference is one, type 5 does kilogram force, and the type 7 does newtons and pounds.
Type 7. Type 7 does the same thing, but it does.
Yeah, they're all the 5 and the 7 are the same. It just has a different unit output. One's kilogram force and one is newtons and pounds.
Okay, so the new type 5 is newtons and kgs.
Yeah, I mean, so if your client doesn't want it, or is only after frequency, there's no point buying a 5 or a 7, because you're just adding more cost. You may as well just look at the type 3 or the type 4. And the other thing I want to touch on really with our handheld belt tension meters is the SKF meter and the Continental meter is actually our meter. We produce it for them. So that's how good the meter is.
You produce that one for Continental
and SKF, yeah.
Okay, I think I saw one unit on your website with the Continental. So then you're like the OEM for them?
Yeah.
Okay.
And that's how we first produced the service meter, as we call it. That was our first product in the belt measurement world. we've been still producing it and we're still selling it now, and that led us into, naturally led us into, mass production facilities and looking at belt applications and the need to collect data now. It kind of sort of in the early 2000s, people people were just buying repeat kind of belt tension meters and things like that. And then as data became critical and production became more data driven, then the sort of FourierBMSs came in. We also do sort of plate mounting belt tension equipment. So we made plates that fit onto Ducati motorbikes. So this, instead of having a control cabinet, we've got a fixture that mounts onto the frame of the motorbike. It's got a hammer in, a bit like the compact sensor hammer. It's got that already built in with optical sensors. It strikes the belt, and we collect the frequency of the belt from it. And Ducati have used our equipment since the late 1990s, both a facility in Italy and in Thailand. So we do other things. As I said, it's not just the FourierBMS we do in the belt tension applications. We do all kinds, and we're open to helping anybody's facility needs. So yeah.
For the Type 5 and Type 7,
they do have an output. They do have an RS-232 output if you want to collect the frequency or the tension. It will output it by RS-232.
do you purchase a sensor, like whether it would be optical or
You get that in the price. So when you buy a meter, you naturally get a sense the sensor head of your
that fits your application?
specification, yeah.
And so the acoustics are the least expensive, and the optical is the cost more.
Yeah.
Okay.
Not massively. You can if you buy the optical meter does have the ability to use an acoustic head alongside it. So you could buy it. So if you buy a sort of Type 4 meter, optical meter, and you find that you might want to try the acoustic head, you could actually just buy an additional acoustic head at a much smaller cost, and then you've got a meter that can work with both acoustic sensor head and an optical.
Which is optical more flexible or robust, or would handle different situations better than the acoustic?
Yes, simply because if you imagine a belt with very low tension in, it will, and if it's got quite a large span length, it will naturally move up and down, let's say 20 millimeters. Whereas if you've got an acoustic head and you're trying to get this to vibrate, it would clash against our sensor head. We have got different size sensor heads with different jaw widths, but it becomes a bit more.
Yeah,
you've got to be a bit more wary. Yeah,
whereas it's more constrained because you have it on both sides of the belt. So the optical, are you only measuring that from one side?
Yes.
Okay, makes sense.
Yeah, but I mean, if I still would, there's still a rule for acoustic sensor heads. It's not, you don't just naturally just say, oh well, optical head can work across everything. It depends on the environment. It depends on you can depend on the makeup of the belt. Don't just ever rule out acoustic sensor heads for your needs, because people still buy them.
Yes. Okay.
Yeah,
sure.
yeah.
And then, is there a way you can email to ProPower what our net cost would be for the belt tensioning product line? Right now, I think I'm interested in either the Type 5 or 7 based on what I think my customer needs, but that could change after I visit with them.
Yeah, we could do that.
Thank you.
It'll be tomorrow, John. Everybody's gone home.
Oh, yeah, that's fine. That's fine. Thanks.
Any more questions?
Not me. Sorry, no, not me.
Neither from my side.
Don't I know there's a lot of information to take on board and just a short time. And I can't stress enough that if you have got any questions, just like I say, send us an email or let's arrange a call and talk things through, because I think the more you understand how our equipment works will allow you to actually take that information and look for and find out whether you really have got a need and what benefits it can give to yourself and your clients.
You're right, Mark. You are right, Mark. Thank you very much. For the moment, I am taking notes of what has been said, and I'm going to investigate a little bit on the terms and the technical data. And taking that, I'm going to have some questions in the future that I'm going to be needing some direct contact with you guys. So yeah, I will send you some emails in future references.
No problem. No problem.
Yes, but from my side, that will be all. I'm very thankful for the information you have given us.
No problem.
You're welcome.
You're welcome. Right. I think we can. Yeah. I mean, it's 52 minutes. I think we can finish that. What's your call, Mark?
Yeah. I don't think there's anything else.
Right.
And if nobody's got any questions, all I would like to say is thank everybody for their time. Much appreciated, and I hope it was informative, and you can take on board what we said. But like I say, there's a lot of information there. Me and Pav may have missed some things as well. Feel free to drop us a call or an email.